All right, hello. Hi. First thing you got back was the lab. On the lab, there were correct answers for limiting reactant excess. So the first trial, the limiter should have been CaCl2, excess should have been Na2CO3. Second trial, limiter should have been CaCl2, excess should have been Na2CO3. But for the third trial, the excess should have been CaCl2, the limiter should have been Na2CO3.
I think you messed up on it. The excess on the third one is CaCl2.
Yes?
You took points off. You took off points for a lot of things.
Okay, I'll check it.
All right.
At the end of the period. There should be a couple minutes. Yes?
Could you put it under the document camera? Because I think I put them in like the wrong order.
Let me see.
Like,
I think I have, here's what it,
first trial wasn't actually the first one I was supposed to do.
let me find mine. Let me find mine.
That might be part why. Like
It could be. If they were out of order,
yeah.
here's what it should have looked like.
Supposed to do first is 75, 75.
Here's what it should have looked like.
Yeah.
So if they were out of order and I didn't realize it,
Yeah, that's why.
LR, excess, LR, excess, excess, LR.
Yes,
Yeah, my first one is wrong, but the rest are right. But you gave me points for my first one.
So I owe you negative points?
I think you just owe
Yeah.
me 2 points.
Owe you 2 points? Okay. That's fine.
So yeah.
That's what I did my original data.
So this one's a 75, 75. And then this one's the one.
So it's just out of order?
Yeah.
Okay.
They're just,
At the end of the period, remind me.
alright.
Have you guys seen? I'm keeping track of these labs on Progress Book for you. On Progress Book, this says what? Lab number, was this 4? So, if you want to, like, write up here number 4, so you keep track, you can. You don't have to, but I'm helping you keep track. People who have points for those labs, remind me. Remind me at the end of the period. Okay, test. Test is next. Here we go for the test. Page 1. There's no letter C on your version of this test. You guys do not have a letter C, so ignore that. The main thing I saw on A and B is many people forgot this last step. I asked for atoms. One molecule of Cl2 has 2 atoms of Cl2 because there's 2. That's 2 atoms of Cl, sorry. So this last step, one molecule of Cl2 has 2 atoms of chlorine. This was the main thing people missed on this first page. I only took up 2 points out of 7 if you missed that extra step. Atoms and molecules are different. Also sig digs. Start with 4 sig digs, end with 4 sig digs. Start with 4 sig, what's so funny? End with 4. Yes?
Like read the problem and we did the complete wrong on number 3.
Oh, well, I'm sorry. I think I gave you partial points. Number 2 is pretty good. Number 2 is pretty good. You should have had 10, 3, 3, 10. Grams to moles, stoichiometric step, moles to mass. So that was worth 7 points. That was worth 7 points. Any questions on page 1? Questions on page 1. Page 2. Page 2, we had our empirical formula. So let me zoom in a little bit so you guys can see how many points this was worth. This question was worth 2, 4, 6, 9, 12 points. It's worth 12 points. So if you had work and you missed like one of these and that carried through everything else, I think I took off 5. If you had no molecular formula at all, I couldn't give you points for it. So I had to take off 3. Once you get to the empirical formula, PnCl2, that's rough molar mass of 114. The molecular formula is 580. So 580 divided by 114 is 5 times 5 times 5 times 5, P5 N5Cl10 for number 3. Questions on number 3. Is that the one that you did the wrong one on?
Yeah, I did carbon.
Yeah.
Chlorine.
Yeah. But you did it correctly just with carbon.
I just think the formula looked a little weird.
So I didn't take off all the points, right?
Right.
Okay. Number 4. This is kind of like our lab. 4A. How can the student correctly conclude the hydrate was heated enough times? It changed by less than 0.001 grams. In our lab, how much did it have to change by? 0.01. So if it's changing by less than 1/1000th, it can be assumed that it's sufficiently dry. So I was looking for something like that. B was iffy. B was iffy. On B, a different student heats the hydrate in an uncovered crucible. Some of the solid spatters out of the crucible. I was looking for 2 things. This spattering will have effect on the calculated mass of water lost by the hydrate. Justify your answer. First of all, I was looking for, it will be greater. You will have more water lost. Why? Because the solid that spattered out had H2O with it. Think about it if it was our lab, the hydrate. Our hydrate, before we did anything with it, had what in it? Water. So if that hydrate spatters out, what is going with that solid? Water. So if I have less water, that means what's going to happen to my calculator? It's going to look like I actually lost more, right? Because the water leaving with it is going to make it look like I actually made it drier. Head nod if that makes sense. Yeah. Questions on those? 2 points, 2 points. Okay. Then we get to this one. On this one, this was unfortunate if you had the wrong limiting reactant. So the first thing you had to do was balance it. Most people got it balanced right. The limiting reactant was copper 2 oxide. Well, just copper oxide. There's no copper 2. How do I know? I know for every 2 of these, I need 3 of these. Or for every 1 of these, I need 1.5 of these. So for every 1 of these, I need 1.5 times worth of this. This times 1.5 is what? Approximately. 1 times 1.5 is 1.5. Do I have 1.5? No. So that's my limiting reactant, which I then run to my theoretical. I run my limiting reactant to the other to figure out how much was used, and then I subtract what I started with, 18 minus what was used to get my excess. Percent yield, actual over theoretical, times 100, 83.2%. That question was worth 1, 3, 5, 10, 14 points. 14 points. So you can see, if you solve for the wrong limiting reactant, but ran your math right, I think I only took out 5, because you carried that mistake forward correctly. Yeah. Cool? Yeah. So I feel like that was pretty fair grading on that one. If you don't show work, I can't give you points. So show work, okay? Show some kind of work so I can give you some kind of points. Cool? Okay, last one. You guys overthought this one. You guys definitely overthought this one. First thing you need to do is balance it. Then it said, what percent of the original 10.2 grams in pure sample was pure TL2SO4? So I took my 0.1964 grams to moles, then I did my stoich step, moles to moles, because for every 2 moles of this, I have 1 mole of this, and 1 mole of that is that molar mass. So this gave me 0.1496 grams of pure TL2SO4. I told you that I had 10.2 impure. Part divided by total times 100. So just 1.467%. Derek did his.
I did it the other way.
He did it the other way? There's another way you can do this. It was super creative, but it worked.
Yeah, I didn't
it worked.
I guess that was the only way to do it.
It worked. No, there's more than one way you could have done it.
Well, I got 1.5 and I'm like, this is definitely.
That's right. You just rounded it. I didn't count sig digs on this one. So 4 points, 6 points. If you had some kind of work, I think I gave you either 4 or 5 out of 10. I forget what it was. Any questions on this one?
If we balanced it, it was 4 points.
If you balanced it, you got 1 point. You got 1 point. Yes?
It was worth 10.
I was thinking, how's this way?
It was worth 11. It was worth 11. What, Derek?
I was thinking, like, how does this other one work? But I mean, I kind of see it.
It does. It does. Any questions on the test?
Did anyone get the bonus points or no?
A couple people got bonus. Yes, let's look at the bonus. A couple people did get the bonus. This first bonus was exactly like our last test, right? Where you were solving for the 1 minus x. So that's why I put this on here. So you could have got 2 bonus points on that. And then this other one was a massive line of stoic. And after you ran that, that gives you your liters. You did do percent yield, and you got 3.14%. I think 1 or 2 people got that. So kudos to the people who got that. It was a massive line of stoic. Not hard. Yeah, that was just time, if you had time to get to that. I have not looked at AP Classroom yet. How many was it? How many questions were there? 6. So we'll have to see. It'll probably be out of 5, I'm guessing. Well, it'll depend on what a 3 is, or what a 5 is. So I set it based off of what AP Classroom tells me. I've not put in your AP Classroom next chapter. I haven't even looked at those yet. Questions on the test? You guys would agree there was no surprises on that test? Okay. I am not here to try and trick you or do anything like that. I'm here to prepare you and for you guys to do well on the test. Questions? Okay, cool, put that away. Excellent. Get out your notes from yesterday. We are going to wrap up most of those. This is where we left off yesterday. I'm going to a new page. I'm going to a new page. Okay. I am recording this, right? Yes. Because some people have to leave. All right, we're going to start out with a new problem here. 17.36 milliliters of 0.250 molar lead to nitrate reacts with 47.61 milliliters of 0.175 molar sodium sulfate. I'm going to ask you 2 questions. And a question like this. First of all, do you guys ever feel like you get behind on eating?
Yes.
So like I played basketball Monday night and Tuesday morning, but in order to play basketball in the evening, I can't eat dinner before I play basketball because it just makes me feel horrible.
That's so valid.
So then I didn't want to eat late Monday night. And then I played basketball Tuesday morning as well. I didn't eat breakfast. So I'm like a meal behind, I feel like.
Yeah, I never eat just have extra snacks. No, I always get that.
I should. But I don't have time to eat snacks right now.
I don't eat it right now because I leave my house at 4:30 and go back to 1:45.
So you guys understand what I'm saying?
Yeah.
Okay. I'm glad that you guys can. Did anyone see the lunar eclipse last night?
Oh, I totally forgot.
It was a full moon and it was visible. I didn't see it though. I went to bed, I was tired.
Yeah, it was.
So, 2 questions I could answer. Number 1, how many grams of precipitate are formed? How many grams of precipitate are formed? We already know how to do this from yesterday. You're going to run both of these, milliliters to liters, liters to moles, very limiting reactant, run to theory. We know how to do that. The second part's new. The second question I'm going to ask is, do you guys know what bracket symbols mean? Concentration. So what is the concentration? So if you see brackets, from now on you know that's concentration of all remaining ions. What is the concentration of all remaining ions? The first thing I want you guys to do is from yesterday, write your balanced equation, figure out your limiting reactant, and figure out how many grams of precipitate are formed. Take 5 minutes and do that first. And we'll do part 2 together. I'm gonna pause mine, start my work. Do you have the right balanced equation? Yes? Okay, keep going. Yes.
I kind of forgot, when we're talking about the obvious, how do you know if it's actually like, would be, like?
So, blue sheet. Which one are you asking about?
I'm thinking about the lead to nitrate, wouldn't that not be because lead isn't?
Number one on your solubility rules. Most nitrate salts are soluble.
Even though it says that exceptions are.
There's no exceptions on number one.
Oh, okay, so this is like a tier list. It's like if it passes one, then it's good.
Right.
If it doesn't, then you go to two.
Because the lead, those are chloride, bromide, and iodide salts. Number three has nothing to do with nitrates. So if it's part of a nitrate, it's soluble.
Okay.
Good question.
I'm trying to just like go down the list.
Yes.
And check off.
Yes, I would go 1, 2, 3. You got it. A salt? Basically ionic, like something from group 1 or group 2 with something in group 16, 17. Positive, negative.
Just if it's an ionic reaction.
Essentially, yeah. Good question. I don't know why I picked such long formulas to do stoic with, but it's fine. I know. I'm sorry.
Terrible to write.
I'm sorry. Stop yelling at me, Ava.
Sorry.
It's okay. It's a 1-to-1, so determining your limiting reactant should be pretty easy, right? Yes? Check step. Did you get PbNO32 as your limiting reactant? Yes? Are we on the same page so far? Okay. So finish it. Zero, zero, 4, 3, 4. Did you guys get your grams of PbSO4?
No, not yet.
Okay. You have like half page left. You guys can watch later. Check yours with mine. Make sure you got the same thing I did. Yes? I will allow that. Yes. I'm not going to take off for rounding. Not going to take off for rounding. 1.33, Ava? You checking?
Yeah, I'm not exactly.
Okay, check it. Thank you for doing that.
Where is the table?
You'll see it. We're good? Questions on what we've done so far? No questions.
Where are they?
Science club table for the club fair. For the club fair. That's where Danny and Haley are too. Science club table. Okay, to do this second part, the second part where it says how many grams of precipitate, or no, what's the concentration of all remaining ions, I'm going to rewrite my balanced equation. You'll see why. So I'm going to rewrite my balanced equation down here. So I'm going to write my PbNO3 to AQ. The states are going to matter. Any guesses why? Partially. Any guesses of why I'm rewriting my balanced equation and I'm also writing the states? Net ionic equation. Yes.
I started doing that before that.
Okay, so I've rewritten my balanced equation. I need to get a net ionic equation in order to determine my remaining ions, concentrations. So first thing I have to do is break these up, right? So PbNO32 is going to break up into what? Pb plus 2 plus what? Plus 2 NO3 minus. Because there's 2. So we hadn't done one like that yet. There are 2 NO3 minus. And if there would have been a coefficient of 2 in front of here, it would have been 2 BP, and 4 NO3. So watch out for that. That's the first one we've done one like that. Plus, how many Na plus ions? 2 Na plus plus SO4 2 minus gives me 2 Na plus plus 2 NO3 minus, because this 2 distributes to both ions, agreed? Coefficient, plus PbSO4 precipitate. I've written my total ionic equation. So I don't really need to do a net because that's not super important on this one. But what I do need to do is determine my spectator ions, right? So spectators are NO3, what else? Na. NO3 and Na. You guys with me so far?
Yeah.
SO4, is that going to be a remaining ion? No. Why is SO4 2 minus not going to be a remaining ion? Because Na2SO4, wait, pause. SO4 2 minus is going to be a remaining ion, right? Because this is in what? My SO4 is excess, yes? So I have excess here. So I know I'm going to have to do something with my SO4 2 minus. Agreed? Okay. Is Na going to be a remaining ion?
No.
Yeah. It's why? It's a spectator. So this is going to be a remaining ion. Is NO3 going to be a remaining ion?
Yeah.
It's a spectator. So yes, it is. So yes, it is. What about Pb plus 2? Pb plus 2 is my limiting ion. This is my true limiting reactant. This is actually the ion that limits the whole reaction.
Leave it to lead.
I know. It's always lead. How do I know that? Well, PbNO32 is my limiting reactant. Agreed? But the NO3 is a spectator. I'm never going to ask you what the limiting ion is, but that's it. That's it. That's it. So that means, what's that? No. You will not have to tell me what the AP, what the limiting ion is, but that's it. So that is a limiting ion. Yes?
It wasn't the SO4.
What wasn't the SO4?
That one's not.
Because this is my limiting reactant, so this is excess, right? So I'm going to calculate the concentration of how many things? 1, 2, 3 things. Are you guys okay with that? Yes? The easiest ones are doing our spectator ions first. So let's start with our NO3. Equation for molarity is molarity equals what? Number of moles over liters. I'm only going to write that once. So let's start out with our molarity of NO3 minus. How many moles of NO3 minus do I have? I have up here 0.00434. Agreed? So I have 0.00434 moles times how many? Times 2. Agreed? Because there's 2 of that 0.00434 because there's 2 NO3s. Are you guys okay with that?
Yeah.
Times 2. Divided by how many liters? What's my liters? So I have to figure out my liters here.
Or is it still the initial?
What is it?
17.
Not 17.36. Not 0.01736.
17.36 is the
That's milliliters. But it's also not 0.01736 liters.
What about,
Do we have to solve for like the
47.
percent?
No percent here. Even simpler than that. Think about what we did. What'd you say? What I did here, didn't I add these two things together? I poured one into the other.
Oh,
So my total liters, you have to add those two together. Does that make sense?
yeah.
So I have to add those two together. So I have to do this plus this because I technically poured those together. Yes?
Okay.
Think about the reaction what I did. I did this many milliliters of this, poured it into the other one. So this plus this gives me a total literage of 0.0 literage. Is that a word? 0.06497 liters. Let's check that. 7, 9, 4, carry the 1. Yes. You guys good with that? You guys agree with this? 0.06497 liters is those two added together?
Yes.
Okay. Solve. That will give us our concentration of remaining NO3 minus. Tell me what you get. Grady's just trusting everybody else. Trust the process. Fine. What'd you get? 0.134 molar NO3 minus. I have one ion done. Now I got to do the same for my Na, right? So molarity of Na plus is going to equal, how many moles of Na did I have? 0.008337 times how many?
2.
Times 2. So 0.00837 moles times 2 divided by what literage? Same literage. 0.0, I love that word. I feel like Danny would add that to his hate list if he was here.
Probably.
Liters. It's still the same total liters. Yes? Solve that. So that will give you your molarity of Na+. Spectator ions are remaining ions. What'd you guys get? 0.2566 molar of Na+. And those were the easy ones.
It would be 2.57. She said 2.566. Right?
Yeah.
Whatever.
It,
Either one's fine. I'm not going to ever take off for rounding to the thousands. Neither is AP Chem. Neither is AP Chem. This last one is my excess. So if I'm going to figure out the concentration of this, what am I going to have to do? Think back to our tires, right? I figured out how many bodies I had, and I had to subtract the tires I started with the tires that I actually did what with? Used. I have to do the same thing with my SO4 2 minus. So I'm going to start out with my limiting reactant, which is 0.00434 moles. So here we go. So 0.00434 moles of PbNO3 2. Stoich step. This is for every 1 mole of PbNO3 2. I'm trying to get this to moles of Na2SO4 because that's what has my SO4 ion, right? Yes?
yeah.
That's a 1-to-1. Is 1 mole of Na2SO4. This will give me my moles of Na2SO4 used. That's what I'm solving for here. How much did I actually use? Agreed? What's my answer? 0.00434 moles of Na2SO4 used. How many did I start with? It's right here. That's how much I started with, yes. So I'm going to subtract my 0.0, am I on the screen? 0.00837, this is my start, minus what I just calculated, the 0.00434 used, and that's going to give me my actual excess. So that gives me 0.00397 moles of Na2SO4 excess. Now I can do molarity of SO4 2 minus. Isn't it amazing how we just made one thing take up almost a whole page? So this equals, how many moles of SO4 do I have? It's right here. 0.00397 moles. Do I have to multiply that by anything? Nope. Divided by what literage? It's still the same literage. Still the same literage. So 0.06497 liters. That will give us our molarity of SO42 minus. Someone do it. Tell me what you get. Daniel, what'd you get?
0.422.
That's not what I got. I got 0.061. What?
I got 0.0614.
0.061. What's your third after the decimal? 1? 1 molar SO42 minus. So, not hard, just a lot of steps. Not hard, just a lot of steps. So, when you're determining your remaining ions, the first thing you have to do is figure out what are your excess ions. It's going to be your spectators and your other thing that's in excess. So usually you're going to be calculating 3 ions. Actually, almost every single time. 3 ions. That's the concentration of all remaining ions. Concentration of all remaining ions. Would you ever have to do that on an AP chemistry test? No, you would not. This would be way too in-depth for one problem on the AP Chem test. Because the AP Chem is trying to test, those are all the units up there, they're trying to test from 3 or 4 units on one question. That's the hard thing about the AP Chem test, is remembering everything we did and applying it all at once. This will be on my test, because you will have to do this in college.
This one need to have FRQ or anything?
No. This is way too in-depth for an FRQ, but you will have to do this on my test. Not hard, just a lot of steps. Also, that's it for the day. Nice work. Yes.